Using a bonding jumper from the feeder conduit to a ground bar as the main equipment grounding conductor for a subpanel is not a good practice and is not in accordance with the National Electrical Code. The National Electrical Code outlines specific requirements for main equipment grounding conductors. The main equipment grounding conductor for a subpanel must be a continuous conductor size according to National Electrical Code Table 250.122. The equipment grounding conductor must be connected to the neutral bar or grounding terminal at the main service entrance panel. Conduit can be used as an equipment grounding conductor, but only if it meets certain conditions. These conditions are: firstly, it must be a metal raceway that is securely connected to all metal enclosures and fittings. Secondly, it must be listed for use as an equipment grounding conductor. Thirdly, it must be continuous without breaks or disconnects. The National Electrical Code does not allow the use of set screw-type fittings as a grounding connection. There are several reasons why using a bonding jumper is not a good practice. Firstly, electrical continuity issues can arise. Bonding jumpers rely on the electrical continuity of the conduit system. Set screw-type fittings can loosen over time, causing poor electrical connections and potentially compromising the grounding system. Secondly, corrosion can be a factor. Bonding jumpers can corrode, especially in areas with moisture or high humidity. This can result in poor grounding and a potential electrical hazard. Thirdly, National Electrical Code compliance. Using a bonding jumper as the main equipment grounding conductor for a subpanel is not in accordance with National Electrical Code requirements. The proper way to ground a subpanel is to run an insulated equipment grounding conductor wire from the neutral bar or grounding terminal at the main service entrance panel to the ground bar of the subpanel. The equipment grounding conductor wire should be sized according to National Electrical Code Table 250.122. For a more detailed understanding, let's delve deeper into the requirements and considerations surrounding equipment grounding conductors and subpanels. An equipment grounding conductor provides a low impedance path for fault current to return to the source. This is essential for the proper operation of overcurrent protective devices such as circuit breakers and fuses. When a fault occurs, a large current flows through the equipment grounding conductor, causing the overcurrent protective device to trip and interrupt the circuit. Without an effective equipment grounding conductor, fault current may not be sufficient to trip the overcurrent protective device, leading to potential hazards such as electrical shock or fire. National Electrical Code Table 250.122 provides guidance on the appropriate size of the equipment grounding conductor based on the size of the overcurrent protective device protecting the circuit. It's crucial to consult this table to ensure that the equipment grounding conductor is adequately sized to handle the potential fault current. When using conduit as an equipment grounding conductor, it is important to ensure that the conduit system is properly installed and maintained. All connections must be tight and secure to provide a continuous electrical path. Additionally, the conduit must be listed for use as an equipment grounding conductor, indicating that it has been tested and approved for this purpose. Set screw-type fittings are generally not recommended for grounding connections due to their susceptibility to loosening over time. Compression-type fittings or other listed grounding connectors are preferred for ensuring a reliable connection. Corrosion can also be a significant concern in grounding systems, especially in damp or corrosive environments. Using corrosion-resistant materials and proper installation techniques can help to minimize the risk of corrosion and maintain the integrity of the grounding system. Regular inspection and maintenance of the grounding system are also essential for identifying and addressing any potential problems before they become hazardous. This includes checking for loose connections, corrosion, and other signs of damage. In addition to the equipment grounding conductor, a subpanel also requires a grounding electrode conductor to connect the grounding system to a grounding electrode, such as a ground rod or metal water pipe. The grounding electrode provides a connection to the earth, which helps to stabilize the voltage and provide a path for stray currents to dissipate. The size and type of grounding electrode and grounding electrode conductor are also specified in the National Electrical Code. It's important to follow these requirements to ensure that the grounding system is properly installed and effective. Furthermore, it's essential to maintain separation between the neutral conductor and the equipment grounding conductor in a subpanel. The neutral conductor should be isolated from the subpanel enclosure, and the equipment grounding conductor should be connected to a separate ground bar. This helps to prevent neutral current from flowing through the equipment grounding conductor, which can create noise and interference in sensitive electronic equipment. In summary, proper grounding of subpanels is critical for electrical safety and the reliable operation of electrical equipment. It's important to follow all applicable national electrical code requirements and best practices to ensure that the grounding system is properly designed, installed, and maintained. Using a continuous, appropriately sized equipment grounding conductor, ensuring secure connections, and preventing corrosion are all essential elements of a safe and effective grounding system. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns about grounding or other electrical issues. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and regulations. Now let's consider some specific scenarios and how the National Electrical Code addresses them. Firstly, consider a situation where a subpanel is located in a detached building. In this case, the National Electrical Code requires that a grounding electrode system be installed at the detached building. This grounding electrode system must be connected to the equipment grounding conductor of the subpanel. This ensures that the detached building has its own grounding reference, which is important for safety and proper operation of electrical equipment. Secondly, let's examine a scenario where a subpanel is fed from a generator. In this case, the National Electrical Code requires that the generator be bonded to the equipment grounding system. This means that the generator frame must be connected to the equipment grounding conductor. This helps to ensure that the generator is properly grounded and that fault current can flow back to the generator in the event of a fault. Thirdly, consider a situation where a subpanel is used to supply power to sensitive electronic equipment. In this case, it may be necessary to install a dedicated equipment grounding conductor to minimize noise and interference. A dedicated equipment grounding conductor is a separate conductor that is run specifically for grounding purposes. It is not used for any other purpose, such as carrying neutral current. This can help to improve the performance of sensitive electronic equipment by reducing noise and interference. Furthermore, it is important to properly label all subpanels and grounding connections. This helps to ensure that electrical workers can easily identify the different components of the electrical system and perform maintenance safely. Subpanels should be labeled with their voltage, amperage, and the location of the main disconnect. Grounding connections should be labeled with their purpose and the size of the conductor. Proper labeling is essential for maintaining a safe and organized electrical system. In addition to the National Electrical Code requirements, there are also a number of best practices that can be followed to improve the safety and reliability of grounding systems. Firstly, it is always a good idea to use high-quality materials and components. This includes using listed and labeled equipment, as well as using corrosion-resistant materials in damp or corrosive environments. Secondly, it is important to follow manufacturer's instructions when installing electrical equipment. This helps to ensure that the equipment is installed properly and that it will operate safely and reliably. Thirdly, it is essential to perform regular inspections and maintenance of the electrical system. This includes checking for loose connections, corrosion, and other signs of damage. Regular inspections and maintenance can help to identify and address potential problems before they become hazardous. In conclusion, proper grounding of subpanels is a critical aspect of electrical safety. It is important to follow all applicable National Electrical Code requirements and best practices to ensure that the grounding system is properly designed, installed, and maintained. Using a continuous, appropriately sized equipment grounding conductor, ensuring secure connections, preventing corrosion, and performing regular inspections and maintenance are all essential elements of a safe and effective grounding system. Always consult with a qualified electrician if you have any questions or concerns about grounding or other electrical issues. They possess the necessary knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes and regulations. They can assess the specific needs of your electrical system and provide tailored solutions to ensure its safety and reliability. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. Remember that electrical safety is everyone's responsibility. Taking the time to learn about electrical safety and following safe practices can help to prevent accidents and save lives. The National Electrical Code is a comprehensive set of standards that covers a wide range of electrical topics. It is updated every 3 years to reflect changes in technology and best practices. Staying up to date on the latest National Electrical Code requirements is essential for electrical professionals and anyone else who works with electricity. In addition to the National Electrical Code, there are also a number of other resources available to help you learn more about electrical safety. These resources include books, articles, websites, and training courses. Taking advantage of these resources can help you to improve your knowledge and skills and become a safer and more competent electrical worker. Electrical safety is a complex and multifaceted topic, but it is one that is well worth learning about. By understanding the principles of electrical safety and following safe practices, you can help to prevent accidents and protect yourself and others from harm. Finally, remember that electricity is a powerful force that should be treated with respect. Always take the time to think about what you are doing before you start any electrical work, and never take shortcuts or compromise on safety. By following these simple guidelines, you can help to ensure that you and others stay safe around electricity. Electrical grounding is a critical safety measure that protects people and equipment from electrical shock and damage. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, tripping the overcurrent protective device and interrupting the circuit. This prevents dangerous voltage from building up on metal parts of equipment, which could cause electrical shock if someone were to come into contact with them. There are several different types of grounding systems, each with its own advantages and disadvantages. The most common type of grounding system is the equipment grounding system, which is designed to ground metal parts of equipment. Another type of grounding system is the system grounding system, which is designed to ground the neutral conductor of the electrical system. The choice of grounding system depends on the specific application and the requirements of the National Electrical Code. The National Electrical Code provides detailed requirements for grounding electrical systems. These requirements cover everything from the size of the grounding conductors to the type of grounding electrodes that must be used. Following the National Electrical Code requirements is essential for ensuring that the electrical system is properly grounded and safe. In addition to following the National Electrical Code requirements, there are also a number of best practices that can be followed to improve the safety and reliability of grounding systems. These best practices include using high-quality materials and components, following manufacturer's instructions, and performing regular inspections and maintenance. By following these best practices, you can help to ensure that your electrical system is properly grounded and that it will protect people and equipment from electrical shock and damage. Remember that electrical grounding is a complex and multifaceted topic. If you have any questions or concerns about electrical grounding, always consult with a qualified electrician. They have the knowledge, skills, and experience to help you ensure that your electrical system is properly grounded and safe.